Good morning, everybody. Oh, so I'm here on behalf of Osama Mohsen, which is my collaborator from Fahd University of Petroleum, who should have been here presenting instead of me, but I'll try my best to deliver on this today. And so, as Weiwei just said, this is a project that is on vision-based automated waste quantification for construction sites. I would say, a project that started about a year and a half ago that is funded by the British Council, where we're looking at waste generation across multiple countries. So the problem is quite familiar to everybody. Construction sites are a very important waste generation point for the world, where most of our landfills are filled with construction waste of a lot of different styles and types. And while we, in certain countries like in the UK, we do a fair bit to remove some of that and try to reconduct some of that waste away from landfills into other types of spaces. The moment you go away into other types of more developing countries like Saudi Arabia, which is one of the cases here, it becomes an extraneous problem where they are actually growing very quickly, generating a lot of waste, and they don't have the capacity to handle of that. So that is where you start to see some headlines on countries actually pushing waste to other countries that can handle that. So that is really a problem. Recyclability is another issue. So that's where we end up having a case of how can we actually tackle waste from a very proactive manner, not just handling or tackling that problem, which is landfills or the space that it occupies, but really looking at getting proactive and giving construction companies a reason to actually be proactive in the waste management process and try to reduce them by their own means. So basically it's talking about the value of waste. And if you look really about, I'm not talking here about demolition waste, it's just purely the waste that is generated on construction sites while the project is ongoing. Okay? So when you really look at building site waste, it's generated and accumulated in different points across sites. Usually if you have a proper waste management process, those sites are really well located in a specific location, move maybe across time, but they are really always in the same space. And what happens is you don't really know what's being thrown in there until basically somebody from usually a third party picks up your skip whenever it's full or whenever it's ready to go, and then it's weighted, and then you basically get charged based of it. So at the end of the project, you know more or less how much weight of waste you've generated across the project because you're being charged for it, but you don't really know how much you've thrown away. So you don't really understand what the value is, all of that. And that is where our really project starts going on. It's like, why can't I just tell you how much waste you're being generated in projects so that you can understand how much you're actually throwing away in terms of money. So that's what this project aimed to tackle, is develop a system that can, understand how much waste is being generated on and thrown away on skips, focusing on really value-added information and providing a quite cost-effective solution, because we understand that we cannot just put like a 60,000 or 70,000 pound system to basically visualize what it's worth, a few hundred maybe. So really cheap system, very simple system, and create a framework around that enables basically construction managers to understand how much is being created and generated in their sites. So the framework, it's quite simple. You have a set of raw materials that go into your construction site, the usual types. So you have bricks, steel, wood, ceramics, etc. And then through different construction process and activities that happen on site, which that is probably the future work that we're trying to link between what is being seen, that generated, and the schedule, for example, of construction site. But so far, the scope of this study that I'm talking today is just whatever happens on the skip, on those collection points, capturing that data through video means. So basically having a camera recording that skip over time, storing that information, and then processing it to understand and basically quantify how much waste is being thrown away. The system is quite simple, as I said. It's just a camera looking up in top of the skip to visualize what is actually going on. Not all of them actually look like that. that is just an AI-generated image. But basically, the temporary structure that you create sometimes might not be necessary. You may use like a scaffolding that is already been in place. You can use any other type of structure that allows you to actually put a camera on top. The camera is like 300 grams, so anything actually can hold it. So usually what you have to do is really just minimize the distance between the skip and the structure that you want, but also at the same time quite put it up so that it has clearance for the skip to be removed, so you don't want to interfere with the waste management process. In this case, more or less, the cameras are usually located between 5 to 6 meters high, so you get an idea that it's a quite high system. But nonetheless, once the camera is installed, and it doesn't really need to be exactly located in the center of the skip, I just know that the skip might be located in one place, and when they remove and put a new one, it could be on a different location, more or less in the same space, but so you have to be flexible in terms of orientation, in terms of angle and position. So it doesn't really matter, really. The algorithm is quite simple. In terms of computer vision, you need to identify or have a way to identify whether the skip is being placed and it's being loaded and unloaded, so that you have a way of defining where, basically what is a skip 1 and a skip 2 and skip 3. You have a waste tracking and classification process that is triggered the moment that there's a skip on the site, and you go frame by frame, basically. That creates a time series of information, and that goes back until whenever the skip is unloaded, and then you start to look into weight quantification and weight composition. And that only happens when the skip has been unloaded. So basically, you capture information until the skip disappears. That is when you calculate all your weight quantification, and then the moment that another skip comes in, you start again. So the algorithm is quite simple. So how do we do the skip load and detection? As I said, everything that I'm going to talk about is quite simple in its complexity. It needs to be simple because we're going on a frame-by-frame basis. And the reason for that is that when you throw in waste into skips, especially if you're thinking of not just somebody by hand throwing something, but really just an excavator bringing up a lot of brick and things, if you really want to look at every single individual brick that is being thrown into, your FPS needs to be, or your frame needs to be very quick. So everything that is filters and they need to be very quick to be processed by a single laptop or anything like that you have attached to the camera. So in this case, it's a very simple background subtraction and motion detection with very simple filters that are basically image processing based. Basically, whenever we see something that is coming into the area that has changed the way that the background looks like, we assume that it's a skip. That means that we have certain moments in which we get false positives. It could be just, there's no skip in place. Somebody walks through, that creates a skip, but it's no big deal. It's easy to filter out because usually there's no waste being thrown to people, so it will be just an empty skip that is easy to filter out. The second part, which is basically tracking exactly how the waste actually goes through the image until it lands on the skip. So we don't really want to continuously capture the same amount of elements, because if you're looking into a skip for many, many times, the frames may look like similar all the time, especially for the things that lay on top, and we don't really want to count for those all the time. So we use optical flow estimation to just see what the path of that specific captured point is, and then once it's stopped, we keep track of that item and we don't count it more than once. So it's mostly to make sure that there's no overinflated counting of the same element in the skip. So basically you throw something once, and even if you detect it for the next 8 hours, it's just once. The only issue that we have from now on is looking at how do you classify the different types of waste. So I talked about raw material at the beginning. Waste classification in the UK, for example, has a very strict regulatory code that has a lot of different types of classification methods. And it defines like 39 different classes and subclasses of waste. And we said, well, we can actually do that. So we use, when we train our model and our AI model, basically we will use that classification. The problem is well, that's not a problem, that it looks like this, for example, in the UK. The problem is when you look at who actually receives that information and to actually trigger some kind of circular economy thing going on, if you look at waste treatment facilities, they only use 13 classes. So that is something that we're actually looking into the future, is how can we put into perspective for some people that actually try to link how both classifications need to be more impaired in order to help us make better classification processes. But anyway, we use, in the end, the 13 classes in a project that was captured in Leeds in the United Kingdom. It's 4 days uninterrupted recording on 2 skips. On 2 skips. Well, 2 skips on each camera, so 4 skips in total. And we use some of that data to train. So we basically labeled about 438 images of all the 7 classes, because I said 13 initially, but there was no, all of the waste was actually visible in those days. So we only had 7 classes. So ceramics, insulation, wood, plastic, brick, metal, and glass. We run it through, I think it was a YOLO V9 something model. And we captured basically all the data as it went through. Finally, in order to get the waste of each one of the classes that is actually being recorded, we run it through this basically a cumulative assessment where you basically divide, it's basically a ratio, if you want, of what's been detected versus the total amount of detections. And this is what you get in terms of results. So for each one of the skips, you get basically a percentage based on the weight that is being estimated, which again, I didn't say it, but we use bulk density in this case of the waste. We don't really know exactly what the density is for each one of the elements because we cannot identify, let's say, a specific type of plastic that's been thrown away. But that is something that in the waste management sector, there's something that is called bulk density. So if you throw a bunch of the same type of material, let's say hard plastic, there's an average density that you can use. So that's what we use in this case. And this is what you get. So you get basically a pie chart, if you want, of what the skip contains. Okay, so it could be, for example, for brick, skip 1, it's about 30% of brick, 30% of insulation, and that is percentages in weight, okay, not in volume, not in a number of things that you've thrown away. So the brick could be considerably low, but it's much more heavier than the insulation, for example, and 13% in plastic. So if we look at, for example, that skip, you will see that you can actually estimate the weight, and we compare the weight of each one of the elements that we captured for each one of the classes. So we went into that skip, we pulled it all out, and then we weighted one by one. So it was a lot of work. And we compare that to what the AI actually thought that the weight was. So if you see, if you see here, actually the model itself cannot do very precise calculations in terms of weight. It doesn't do that very well. It underperforms usually very heavily by about 30 to 40%. And that is fine because what we're really looking for is actually the composition of the skip, which tends to be extremely accurate in its estimation, okay? And the reason for the weight being wrong is because usually what we do estimations in terms of the shape of the form, since we're using very simple classification methods, not segmentation or anything like that, because we want simple outcomes. The volume obviously is definitely wrong, but in terms of that error that is being transported on any single estimation kind of evens out across all the different classes. So when you get a lot of data, it basically evens out and you get quite an accurate estimation in total, right, of all of the other ones. You get more or less of a 3 or 4 or 5% of error. So conclusions, this is actually a quite alternative method to waste audits to get an estimation of what is actually the waste composition that you can create across construction sites. It provides a certain degree of automation that should enable at least construction sector to actually start to understand more about waste generation in the projects, and obviously to reduce also the cost of those waste audits that actually happen on site. Especially in the UK, it's very important for hazardous materials. And then, well, there's still issues that we need to go through in terms of all the stakeholders that should be aware of this type of material waste classification going on, that require maybe a lot of more coordination to actually enable like a more streamlined process in terms of information that is being generated by the system. And obviously try to tie these results with what actually happens on site is our next stage, to try to understand really why there is this type of waste being generated that day. If that's something that we can tie, for example, to BIM schedules, it would be something very interesting, because if we can tie activities to actually what's generated, then the waste will become less of a surprise in the day that it actually comes in, and more like of an expected number that we can then compare to see, for example, if there's any unprecedented activities going on site. And that's it for me. Thank you very much.